Hello guys. So in this video you are going to see, as I have mentioned in my earlier class, that what was a temperature coefficient, and we came to know that with every 10 Kelvin rise in the temperature, the rate of the reaction nearly doubles or triples. Of course, whatever I have said, it was a theoretical basis. So in this video we are going to see that how graphically one can explain that temperature coefficient. That is why on increasing the temperature by 10 Kelvin, your rate of the reaction increases. So we are going to study this part in the concept under the headline called as explain the effect of temperature on the rate of reaction graphically. So whenever in your exam they have been asking you to indicate the effect of temperature graphically, then you have to use this answer. Okay, so now let us begin with it. So first and the foremost thing, let us plot a graph. Of course, I would be choosing a graph which I have plotted earlier. That has been given in your notes too. Do remember in notes I was able to not give you as T and T plus 10 Kelvin. Please note it down in your respective graphs. Okay, let's begin with it. So basically here, whatever the y-axis you are seeing, it represents the fraction of your reacting molecules. In some of the books, you can also see it will be written as n subscript E divided by n subscript T. Not a great matter. It is which is representing the fraction of the reacting molecules. Of course, I would be dealing with what does that fraction also refers to in my later part. So now just for a while you remember what does your y-axis is representing? Fraction of your reacting molecules. Yes. And your x-axis is representing that of your kinetic energy. If you can just pay a notice over here, this is my first graph what I have obtained at a temperature of T Kelvin. Remember, in this graph, whatever the peak is there, what is that? Whatever the peak is there, that is mainly corresponding to the most probable kinetic energy. What does it represents? Whatever the peaks you are observing in both the curves, that represents what? Most probable kinetic energy. Then what do you mean by this most probable kinetic energy? So what does it say? It means it is the kinetic energy of maximum fraction of molecules. It is the kinetic energy of maximum fraction of molecules. 100 molecule idre adal ಒಂದು 70 molecule ಎಷ್ಟು kinetic energy ಇರುತ್ತೋ, I'm just giving an example, okay? If you are having 100 molecules, among that one, if 70 molecules, whatever the kinetic energy is there, that is called as what? Your most probable kinetic energy. And what does it indicates? Your peak of the curve. So of course, when you are seeing, it is for T Kelvin, and another graph, what does it shows? It is for T plus 10 Kelvin. But what is we are observing over here is, on increasing the temperature, please mark my words. So this is at T Kelvin, I have obtained a graph. Same reaction is done at some T plus 10 Kelvin. So what we can observe, thus there is a slight shift. There is a shift in this energy curve towards that of your higher energy. Please mark my points. So on increasing the temperature, what is happening? There is a shift of your energy curve to that of your higher energy. So what happens? Of course, whatever the fraction of molecules are there, they are getting an extra energy. Able to understand? So what happens when the shift is taking place? So what happens over there? There is a greater proportion of the molecules will be having the higher energies. Yes. So of course what happens now? These molecules will get to collide, and that will reach to the product. Of course we know that. But now the question arises that, of course, sir, if you consider, as I have written, this is your energy of activation. Of course your T Kelvin is also having those molecules, and T plus 10 Kelvin is also having those activated molecules. Then only why T plus 10 Kelvin is giving you the higher rate of reaction. So now when the question is like this, you have to assume that if I am considering that this is my activation energy, what is this? Energy of activation. If I am going to choose the two areas of the respective curves, that is the area under A, B C and D. Yes. So this is the area of the molecules. Remember, it is this area A, B, C, D. It represents what? An area. And what does this area represents? It represents the number of the fraction of molecules. Yes, please mark my points. Number of the fraction of molecules having the energy equal to or greater than that of your activation energy. Once again, I am saying whatever the area we are going to see over here, it mainly represents what? The fraction of molecules having the energy equal to the activation energy or greater. Yes, greater than that of your activation energy. So this was with respect to which curve? T curve. So if I'm going to extend this, that is A, B, E and F. Of course, what we could see, it is double the area of A, B, C, D. Alva. So what happens if you just see this, here the number of the activated molecules are less. But when I am considering for a T plus 10 Kelvin, what has happened? The number of the activated molecules are more. And we know that when the number of the activated molecules increases, what happens? It leads to the effective collision, and that will be giving you the product at a faster rate. So this is what we can explain graphically about the concept of your temperature coefficient. In temperature coefficient, we were knowing what? With every 10 Kelvin rise in the temperature, the rate of the reaction nearly doubles or triples. Of course, why in this case what you can say, it is doubling. Why it is doubling? Because whatever the area we are seeing over here with respect to the curve of T plus 10 Kelvin, it is two times more than that of your T Kelvin curve. And whatever the line we are seeing over here, it is representing your what? Energy of activation. So whatever the area of the particular curve represents, what does it represents? The fraction of molecules having the energy either equal to activation energy or greater than activation energy. So if the number of the molecules are much more which are activated, of course that will be resulting in a greater rate of the reaction. That is the reason we are saying that with every 10 Kelvin rise in the temperature, the rate of the reaction nearly doubles or triples. So this is one of the fact which I wanted to explain. And another most important thing, when I was explaining with respect to that of your Arrhenius equation, what did I say over there? Yes, K is equals to A into e to the power of minus EA divided by RT. Alva. Of course, I gave you each and everything. But now when the question arises that, what is this e to the power of minus EA by RT? Remember, the exponential term, whatever this is there, Alva, it mainly represents the fraction of molecules. What does it represents? The fraction of molecules that are having the kinetic energy, greater than, what is that? Greater than that of your activation energy. Remember, overall this factor, the exponential part, e to the power of minus of EA by RT, what does it represent? The fraction of molecules having the kinetic energy greater than EA. If I am going to choose my graph, of course, whatever this area part molecules are there, ಇಲ್ಲಿ ಎಷ್ಟು molecules ಉಂಟು ಆ ಪಾರ್ಟ್ ನ ನಾವೆಲ್ಲಿ ನೋಡಬಹುದು Arrhenius equation ಅಲ್ಲಿ ಈ exponential part ಅಲ್ಲಿ. So in case if you are going to calculate this and whatever the value you are going to get, what does it represent? It will be the fraction of the molecules having the kinetic energy greater than EA. Or in simple words, what does it indicate? The number of fraction of the number of activated molecules. Okay, so this is the thing we have to remember, because of course I don't hope so that is written in your textbook, but most of your competitive exams they are going to ask it. What does this factor represents? So once again I am repeating, fraction of the molecules having the kinetic energy greater than that of your activation energy. So coming back to that of, I am giving once again the explanation, whatever we have chosen over here. Of course, it is the explain the effect of temperature on the rate of the reaction graphically. So whenever they are asking this question, you have to represent this graph itself. So what this graph is saying? So first we are going to get a plot of a graph which will be measured for T Kelvin, which is a plot of your fraction of reacting molecules versus your kinetic energy. So on increasing the temperature by 10 Kelvin, what has happened? There is a shift in the curve has been observed. So of course, what does it represent? Of course, whatever here part are there, that is mainly representing your number of the molecules. So when it has been shifted to higher energy and Artha, that fraction of molecules have obtained an extra energy. Yes. So at T plus 10 Kelvin, we have obtained the molecules. Yes, obtained the molecules somewhat of greater energy. So when such greater energy is observed, we are seeing that there is an activation energy for both the curve, which is represented over here. That is your AD and AF. This line represents what? Your energy of activation. But now when the question arises that why does the rate of the reaction increases for T plus 10 Kelvin? Of course, we know that if the molecules are having the energy greater than that of your activation energy, their collision will give us the product. And one more thing we know, as the number of the collisions increases with respect to the activated molecules, yes, what happens? Your rate of the reaction also increases. So when we are saying the area, this area, that is A, B, C, D. So this area represents what? The fraction of the molecules having the energy greater than that of your EA. Yes. But when the same thing is observed in the area of A, B, E and F, what you can observe? It is the double the area. Alwa. So it contains twice the number of the fraction of molecules having the energy greater than that of your activation energy. Of course, when the number of the activated molecules increases, the number of the collisions also increases. So when the collision between the activated molecule increases, what happens? At a faster rate, you will be obtaining your products. That is the reason we are explaining that with increase in the temperature, the rate of the reaction also increases. And in an Arrhenius equation, we have obtained an exponential factor. And what does this factor indicates? So it mainly indicates the fraction of the molecules having the kinetic energy greater than that of your activation energy. That is whatever this area wise we are saying, that is mainly explained with respect to that of your Arrhenius equation to your term of exponential term, that is e to the power of minus EA by RT. So you have to guys remember that we have seen the two factors. One, with respect to the concentration of the reactants, very much important. There we saw how to write a rate equation. Yes, how to calculate the order of the reaction. What is the difference between the order and the molecularity of a reaction? The elementary and the complex reactions also we observed over there. And the most important thing, what did we see over there? That whichever the reaction which is taking place at a very slowly, that is called as your rate determining step. Of course, I was thinking that you would be asking me a question. Why, sir? So let me give you an example. That is, in case there is a destination over here. Okay, there is a destination over here and you have been given a team of A, B, C, D. This represents the first team. And okay, so what is the task? When all the team members are coming to this destination, I am going to stop my stop clock. Of course, among these four fellows, if I choose that, this C is one of the laziest fellow. Okay, one of the lazy fellow. Of course, this A has come, stop clock is running. This B has come, stop clock is running. This D has come, stop clock is running. When does this stop clock can stop? Only when this C also approaches the destination. Similarly, when a reaction is taking place in a multiple steps, when does your reaction stops? And I'm going to get my velocity, the final velocity, when the slowest step reaction takes place, alva. When the slowest step reaction takes place. That is the reason I mentioned over there that whichever the reaction which is taking place at a slowest step will be your rate determining step. Of course, there I was much confused that why didn't you ask? There are two reasons. Either you should have understood it or otherwise you have not understood it. In case you have not understood it, I hope this would be a greater example. 4 ಜನ ಓಡಬೇಕು, ಒಂದು ಡೆಸ್ಟಿನೇಷನ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಏನ್ ರೂಲು ಅಂದ್ರೆ 4 ಜನನು ಆ ಡೆಸ್ಟಿನೇಷನ್ ಮುಟ್ಟಿದ್ರೆ ಮಾತ್ರ ನಾನು ಸ್ಟಾಪ್ ಕ್ಲಾಕ್ ನಾನು ಸ್ಟಾಪ್ ಮಾಡ್ತೀನಿ. ಎ ಬೇಗ ಓಡ್ದ, ಬಿನು ಬೇಗ ಓಡ್ದ, ಡಿನು ಬೇಗ ಓಡ್ದ, ಸ್ಟಾಪ್ ಕ್ಲಾಕ್ ಇನ್ನೂ ಓಡ್ತಾನೆ ಉಂಟು. ನಾನೀಗ ಏನ್ ಮಾಡ್ತೀನಿ, ಸಿ ಯಾವಾಗ ಮುಟ್ತಾನೆ ಅನ್ನೋದನ್ನ ಕಾಯ್ತಾ ಕೂತೀನಿ. ಸಿ ಬಂದ್ ಮುಟ್ಟಾಗ ಏನಾಗುತ್ತೆ, ದ ಸ್ಟಾಪ್ ಕ್ಲಾಕ್ ಹ್ಯಾಸ್ ಬಿನ್ ಸ್ಟಾಪ್ಡ್. ಅವಾಗ ಒಂದು ವೆಲಾಸಿಟಿ ಸಿಕ್ತು ಅಲ್ವಾ. ಇದು ಮಾನ್ಸ್ಟರ್ ಕೇಸಲ್ಲಿ ಆಯ್ತು. ರಿಯಾಕ್ಷನ್ ಕೇಸಲ್ಲಿ ಅಲ್ವಾ ನಾವೇನ್ ತಗೊಂತೀವಿ, ರಿಯಾಕ್ಟೆನ್ಸ್ ತಗೊಂತೀವಿ. ಆ ರಿಯಾಕ್ಟೆನ್ಸ್ ಏನಾಗುತ್ತೆ, ಕಾಂಪ್ಲೆಕ್ಸ್ ಸ್ಟೆಪ್ಸ್ ಹೋದಾಗ ಯಾವುದೋ ಒಂದು ರಿಯಾಕ್ಷನ್ ತುಂಬಾನೇ ಸ್ಲೋ ಆಗಿ ನಡೀತಾ ಉಂಟು. ಅರ್ಥ ಏನು, ಅದ್ರ ಮೇಲೆ ನಿಮ್ಮ ರೇಟು ಡಿಪೆಂಡ್ ಆಗಿದೆ. ದಟ್ ಈಸ್ ದ ರೀಸನ್ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ, ಯಾವ ರಿಯಾಕ್ಷನ್ ತುಂಬಾ ನಿಧಾನಕ್ಕೆ ನಡೀತಾ ಇರುತ್ತೋ ದಟ್ ಈಸ್ ವಿಲ್ ಬಿ ಕಾಲ್ಡ್ ಆಸ್ ವಾಟ್, ರೇಟ್ ಡಿಟರ್ಮೈನಿಂಗ್ ಸ್ಟೆಪ್. ವೆರಿ ಮಚ್ ಇಂಪಾರ್ಟೆಂಟ್ ಕಾನ್ಸೆಪ್ಟ್. Okay, so with the increase in the concentration of the reactants, your rate of the reaction also increases. That is the final thing we have to come to know. And coming with respect to the effect of the temperature also we saw, that is what, with increase in the temperature, the rate of the reaction also increases. And majorly we learned over there the temperature coefficient part. And as a sort of graphical representation we saw how does your T plus 10 Kelvin curve lies over there, and how does with respect to increase in the area of which represents the fraction of the molecules having the energy greater than activation energy will be higher, and that will be leading to the higher rate of the reaction. So next factor we are going to see in our next video, that will be the effect of catalyst. What is that? The effect of catalyst on the rate of the reaction. Yes guys, so let us move to the next video. Okay. So guys, when I was representing the graph, of course I said you that this was my energy of activation, and you can just notice that I have accurately put it over here. Now when the question arises that, sir, how can I determine this energy of activation? Of course, by merely we can't write anything, alva. Ishudanga na ಏನು ತೋರಿಸ್ತಿದೆ, ಯಾವುದೋ ಒಂದು ರಿಯಾಕ್ಷನ್ ಬರ್ದಾಗ ಇಲ್ಲಿಗೆ ತೋರಿಸ್ತಾ ಇದ್ದೆ ಅಲ್ವಾ. ಬಟ್ ಇಲ್ಲೇನ್ ಮಾಡಿದೀನಿ ನಾನು, ಇದನ್ನ ನಾನು ಸ್ವಲ್ಪ ಕೆಳಗೆ ಭಾಗದಲ್ಲಿ ತೋರಿಸ್ತಾ ಇದ್ದೀನಿ. ಯಾಕೆ? Of course, the reaction coordinate has been changed. That is a different scenario. But the main concept is, how can I come to know what will be the value of activation energy? Yes. So when this concept was arised, by utilizing that of your Arrhenius equation, we derived a formula depending upon the two temperatures and to that of your two rate constant, which is very much important formula. So in this video, we will be mainly dealing with that formula. Okay, so what does your Arrhenius equation says? Yes, the K is equals to A into e to the power of minus EA by RT. Yes, let me take ln on both sides. That is ln K is equals to what? It is the product, that will be ln A minus EA by RT. Alva ಬರ್ಕೋಬಹುದು ಅಲ್ವಾ ಈ ತರ ನಾನು. There is nothing. ಇಲ್ಲಿ ln A ಬರುತ್ತೆ, ln A into ln of e to the power of minus EA by RT. So power ಮೇಲೆ ಏನಿರುತ್ತೆ ಅದನ್ನ ಬರ್ಕೊಂಡಿದ್ದೀನಿ ಅಷ್ಟೇ, nothing much more. So ಇಲ್ಲೇನಾಗುತ್ತೆ ಈಗ, ln K ಇದ್ದಿದ್ದು at temperature T1 ನೋಡೋಣ. ಎರಡು ಟೆಂಪರೇಚರ್ ನಾನು ಮೆಜರ್ ಮಾಡ್ತೀನಿ. at temperature T1 ಅವಾಗ ನಾನೇನಾಗುತ್ತೆ, ನನ್ನ ರೇಟ್ ಕಾನ್ಸ್ಟೆಂಟ್, ಅಫ್ಕೋರ್ಸ್ ನಾನು ಹೇಳಿದ್ದೆ ಟೆಂಪರೇಚರ್ ಚೇಂಜ್ ಆದ ಕೂಡ ನಿಮ್ಮ ರೇಟ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಚೇಂಜ್ ಆಗುತ್ತೆ. ಲೆಟ್ ಮಿ ಟೇಕ್ ದಟ್ ರೇಟ್ ಕಾನ್ಸ್ಟೆಂಟ್ as what, ln of K1. So that will be equals to what, ln A minus EA ಚೇಂಜ್ ಆಗಲ್ಲ, ರೇಟ್ ಇದು ರಿಡ್ಬರ್ಗ್ ಗ್ಯಾಸ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಚೇಂಜ್ ಆಗಲ್ಲ, ಟೆಂಪರೇಚರ್ ಚೇಂಜ್ ಆಗಿದೆ ಅಲ್ವಾ. ಸಿಮಿಲರ್ಲಿ at temperature T2 ಏನಾಗುತ್ತೆ, at temperature T2 ln K2 is equals to what I can write, ln A minus EA divided by R times of T2. Yes, let me subtract. If I consider this one as A and this one as B, what can I do? I will do it as B minus A. Yes, so I can write it as ln of K2 minus ln of K1 is equals to what? Of course, ಇವೆರಡು ಕ್ಯಾನ್ಸಲ್ ಆಯ್ತು, ln A ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಸೊ ನನ್ನ ಹತ್ರ ಉಳಿಯೋದೇನೀಗ, EA by R T2 minus EA divided by R times of T1. Yes, of course, log A minus log B ಆಗಿರ್ಬೋದು. ಅಥವಾ ln A minus ln B ಯಾವ ತರ ಬರ್ಕೋಬಹುದು, ln of K2 by K1 ಬರ್ಕೋಬಹುದಲ್ವಾ. So that is equals to ಎರಡು ಕೇಸಲ್ಲೂ ನಿಮ್ಮ EA by R is constant. Let me take it out. EA by R. So 1 by T2 minus 1 by T1 ಬರ್ಕೋಬಹುದಲ್ವಾ? Yes. Anything else? ಈಗ ಏನ್ ಮಾಡ್ಬೇಕು ನಾನು ಲ್ಯಾನ್ ನ ಲಾಗ್ ಮಾಡ್ಕೊಂತೀನಿ. ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ log K2 divided by K1 is equals to what? 2.303 ಆಗಿರುತ್ತೆ. 2.303 ನ ಕೆಳಭಾಗದಲ್ಲಿ ತಗೊಂತೀನಿ. EA divided by 2.303 into R of 1 by T2 minus 1 by T1. So if you are noting over here, of course temperature ಎರಡು ನಮ್ ಕೈಲಿ ಇರುತ್ತೆ. ಸೊ ಆ ಪರ್ಟಿಕ್ಯುಲರ್ ಟೆಂಪರೇಚರ್ ಇನ ರೇಟ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಸಿಗುತ್ತೆ. ಅಫ್ ಕೋರ್ಸ್ ಇಲ್ಲಿ ನಮ್ಗೆ ಏನಿದು ಆರು ನಿಮ್ಮ ಗ್ಯಾಸ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಅದು ಕೂಡ ಕಾನ್ಸ್ಟೆಂಟ್. ಸೊ ಎಲ್ಲ ಟೆಂಪರೇಚರು ರೇಟ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಮತ್ತೆ ಗ್ಯಾಸ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಗೊತ್ತಿದ್ರೆ easily one can measure your activation energy. Do remember guys, very important formula. Soon after your integrated and half-life, this is one more formula we are going to use. Yeah, pakka one problem antu idde irutte idru mele, so you have to majorly understand. Don't get confused over here. It is log of K2 by K1, not K1 by K2. ಇವೆಲ್ಲ silly mistakes ನೀವು ಮಾಡ್ತೀರಾ ಯಾವಾಗಲೇ ನೀವು ಒಂದು ಫಾರ್ಮುಲಾ ಹಾಕ್ತಿದ್ದೀರಾ ಅಂದಾಗ. ಒಂದು ಫಾರ್ಮುಲಾ ಮಿಸ್ ಆಯ್ತಾ overall wrong answer. They will not give you a single marks. So you should pay attention. Log of K2 by K1 is equals to what? EA divided by 2.303 into R of 1 by T2 minus 1 by T1. Remember, this formula is also called as an alternate form of your Arrhenius equation. Alva? Arrhenius equation actually namge idittu, which was very simple to understand. So this part, whatever we have obtained the final expression, it is also called as an alternate form of your Arrhenius equation. So if I am going to plot a graph, for example, ln of K versus that of your 1 by T. Yav tagonತೀನಿ ನಾನು equation no ln K is equals to what? Minus of EA by RT plus ln A. Alva? Ln K is equals to minus of EA by RT of plus ln A. Of course, ln K versus 1 by T ಅಂತ ತಗೊಂಡಿದ್ದೀವಿ. ಇದು y axis, ಇದು x axis. ಸೊ ಇದೇನಾಗಬಹುದು 1 by T ಅಂದ್ರೆ ನಿಮ್ಮ ಸ್ಲೋ ಇದೇನಾಗಿರುತ್ತೆ m minus of EA by R. Of course, it is having an intercept, but whatever the slope is there ಏನುಂಟು ಮೈನಸ್ ಉಂಟು. ಸೊ ಈಗ ನಾನು ಇದನ್ನ ಗ್ರಾಫ್ ನ ಪ್ಲಾಟ್ ಮಾಡಿದ್ರೆ ಏನ್ ಸಿಗ್ಬೋದು ನಿಮ್ಗೆ? ಎಸ್, here is your ln K, here is your 1 by T. So this will be your graph. Of course, whatever the intercept part is there, that will be what? Yes, that will be giving you as ln A. Remember, frequency factor kuda ನಾವು ಕಂಡುಹಿಡಿಬಹುದು ಅಲ್ವಾ? A value kuda ಈ ಒಂದು ಗ್ರಾಫ್ ಇಂದ ನಾವು ಕಂಡುಹಿಡ್ಕೋಬಹುದು. These are the things you have to understand. Of course, ln A ಏನು ಬರುತ್ತೆ? A ಏನ್ ಬರುತ್ತೆ ಅವಾಗ ಏನ್ ಆನ್ಸರ್ ಸಿಕ್ಕಿರುತ್ತೋ ಅದು ಆಂಟಿ ಲಾಗ್ ತೆಗೆದ್ರೆ ಏನಾಗುತ್ತೆ ನಮ್ಗೆ A ಸಿಗುತ್ತೆ. ಮತ್ತೆ ಇನ್ನೇನು ಉಳ್ಕೊಂಡಿದೆ? Of course, the graph ಇಂದ ಏನ್ ಸಿಗುತ್ತೆ ನಮ್ಗೆ? Sorry, slope in the whatever the slope is there, that we are going to get as what? Minus of EA by R. Of course, R is a constant, so one can easily measure that of your EA. That is your activation energy. But even the graph in the you can just observe that how many quantities we can get. Alva? So these are the things. One, ಯಾವುದೇ ಒಂದು not only in your chemistry part, ಯಾವುದೇ ಒಂದು derivation ಮಾಡಿದಾಗ ಅದೊಂದು expression ಬಂದ್ರೆ, remember that scientists always try to do it in the form of y is equals to mx plus c, because we know it's a straight line, and utilizing that straight line one can easily find the intercept, the slope, alva, which are very much important for your further calculations. So these are the things you have to keep in your mind being a science student, that how to convert a derivation and convert it into a form of that of your y is equals to mx plus c. So in this video, we have mainly seen that what is an alternate form of an Arrhenius equation, that is log of K2 by K1 is equals to EA divided by 2.303 into R of 1 by T2 minus 1 by T1. So these are the two different temperatures. Okay. So two different temperatures ಗೆ two different rate constants ಇರುತ್ತೆ. ಸಿಕ್ಕುತ್ತೆ ಎಲ್ಲದೂ ಗೊತ್ತಿದ್ರೆ ನಾವು ಈಸಿಯಾಗಿ ಏನ್ ಮಾಡಬಹುದು EA ವ್ಯಾಲ್ಯೂ ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬಹುದು. Then we saw that if you are going to plot a graph, ಹೆಂಗ್ ತಗೊಂಡ್ವಿ ಇದನ್ನ ln K versus 1 by T. By utilizing this equation, they have mainly chosen it. So again, ಆಯ್ತು ln K is equals to minus of EA by RT plus ln A. ಒಂದು equation ಮಾತ್ರ ಈ equation ನ ತಗೊಂಡಿದ್ದಾರೆ. ಜನರಲ್ ಆಗಿ ಅಲ್ವಾ. ಅವಾಗಿದೆ ಅದು y is equals to mx ಅಲ್ವಾ, ಮೈನಸ್ ಆಫ್ mx ಪ್ಲಸ್ ಸಿ. ಸೊ ಆ ಇಕ್ವೇಶನ್ ಅಲ್ಲಿ ನೋಡ್ಕೊಂಡ್ರೆ ನಮ್ಗೆ ಈಸಿಯಾಗಿ ಏನ್ ಆಕ್ಟಿವೇಶನ್ ಎನರ್ಜಿ ಉಂಟು, ಏನು ಓರಿಯಂಟೇಶನ್ ಫ್ಯಾಕ್ಟರ್, ಸೊ ನಾಟ್ ಓರಿಯಂಟೇಶನ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಫ್ಯಾಕ್ಟರ್ ಏನುಂಟು ಅಂತ ಈಸಿಯಾಗಿ ಗೊತ್ತಾಗುತ್ತೆ. ರಿಮೆಂಬರ್, ಫ್ರೀಕ್ವೆನ್ಸಿ ಫ್ಯಾಕ್ಟರ್ ಅಂತ ಯಾಕೆ ಹೇಳ್ತಿದ್ದೀನಿ, ಮೇನ್ಲಿ ಇಟ್ ಇಂಡಿಕೇಟ್ಸ್ ದಟ್ ವಾಟ್ ಈಸ್ ದಿ ನಂಬರ್ ಆಫ್ ದಿ ಕೊಲ್ಯೂಷನ್ಸ್ ದಟ್ ಇಸ್ ಟೇಕಿಂಗ್ ಪ್ಲೇಸ್ ಅಟ್ ಪರ್ ಸೆಕೆಂಡ್. ಆ ರೀಸನ್ ಇಂದಾನೆ ನಾವು ಇದನ್ನ ಏನಂತ ಹೇಳ್ತೀವಿ, ಏನ ಫ್ರೀಕ್ವೆನ್ಸಿ ಫ್ಯಾಕ್ಟರ್. ಫ್ರೀಕ್ವೆನ್ಸಿ ಅಂದ್ರೆ ಏನು, ಅಫ್ಕೋರ್ಸ್ ಯು ಆರ್ ಗೋಯಿಂಗ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ವೇವ್ಸ್, ನಂಬರ್ ಆಫ್ ದಿ ವೇವ್ಸ್ ದಟ್ ಪಾಸಸ್ ಥ್ರೂ 1 ಸೆಕೆಂಡ್, ಎಷ್ಟು ವೇವ್ಸ್ ಪಾಸ್ ಆಗುತ್ತೆ ಅದನ್ನ ಏನಂತ ಹೇಳ್ತೀವಿ, ಫ್ರೀಕ್ವೆನ್ಸಿ ಅಲ್ವಾ. ಇಲ್ಲೇನ್ ಹೇಳ್ತಿದೀವಿ, ನಮ್ಮ ಕೊಲ್ಯೂಷನ್ ಥಿಯರಿ ಪ್ರಕಾರ 1 ಸೆಕೆಂಡಿಗೆ ಎಷ್ಟು ಕೊಲ್ಯೂಷನ್ ಆಗ್ತಾ ಉಂಟು ಅದನ್ನ ಏನ್ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡುತ್ತೆ, ಯೋರ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಫ್ಯಾಕ್ಟರ್. ಓಕೆ, ಸೊ ದಿಸ್ ಇಸ್ ಒನ್ ಆಫ್ ದಿ ಮೋಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಫಾರ್ಮುಲಾ soon after your integrated rate equation and that of your which one, half life. Okay.